important notes about online learning. Download the slides and go through them along with the video or audio. You still need to make notes and try and express things in your own words, and this is going to be important to develop your own understanding. You still need to go through your manual and do all the work points. You still need to explore further through additional reading, online investigation, etc. For example, YouTube has some wonderful linguistic resources. While doing online learning, it becomes even more important that you do these things. You will need to manage your own time and take responsibility for your own learning. During the course so far, we've been talking about grammar. We've mentioned the word universal grammar a couple of times. And I'd like to take the time in this lecture to speak in a bit more detail about universal grammar and why we might want to assume something like that might exist. Full disclosure, I'm a syntactician myself and I work in this area, and I would also consider myself a Chomskyan generative syntactician. So my leanings are very much toward universal grammar. I'd like to consider a number of arguments for why universal grammar might exist. I'm not trying to be comprehensive, and there are a lot of details that will have to be left out, but you're also welcome to explore these in your own time. One kind of argument in favor of universal grammar is because there exist interesting similarities between languages. Now, of course, we expect languages to be similar when they're related or when there's been contact and borrowing between languages. But what about situations where languages developed independently of each other and yet end up with similar features? Now, there are many of these kinds of features. I'm just going to focus on one on this particular slide, namely double negation. So if you want to express negation in French, what you do is sandwich the verb between two negative particles, ne as a prefix and pas as a suffix. This would get you something like je ne mange pas beaucoup, which means I do not eat very much. Interestingly enough, ACQUISTION also has a double negation. In the sentence andifuni ukusebenza, the a prefix indicates negation, and the e suffix indicates negation as well. So in a way it is similar to French because the verb is sandwiched between two negative particles. We can see a similar process at work in Afrikaans. Ek wil nie swem nie. Here again the verb is sandwiched between the first nie and the second nie. Well, finally, what about English? In English you would say something like, I don't have any. So surely that would be a counterexample. Well, yes and no. First of all, note that in many English dialects, the any would be replaced by negative. For instance, I don't have none. In this instance, there's a negation, don't, before the verb, and another negation word, none, after it. So it would appear the verb is sandwiched between two negations. But let's look at I don't have any again. What's actually going on there? You'll notice that if you take away the first negation, then the sentence becomes ungrammatical. I don't have any versus I have any. So it would look as if the second any is somehow dependent on the first negation. So one possible analysis would be to say that any is a kind of a negative particle. We might call this a negative polarity item. If we analyze any as a negative particle in this way, then it would seem then English does show the sandwich pattern. There are many examples like this of languages that have curious and oddly specific similarities even though there's no contact or no genetic relationship between those languages. The question to ask is, if language is just like culture, and like culture is infinitely variable, what are the chances of there being any generalizations at all? Clearly there seems that there is some limitation to the kind of variation that can occur between languages. And where does this limitation come from? Well, one answer is that it comes from the fact that we have the same brain, and that we have the same language faculty, and that we have the same universal grammar. Some of the longest standings and most traditional arguments for universal grammar come from the area of language acquisition by small children. Chomsky argued that language acquisition contexts were characterized by something called the poverty of the stimulus. What he meant by that was that real language, when you listen to it, is very chopped up, lots of incomplete sentences, there's a lot of ungrammaticality, there's a lot of stops and starts, and not all kinds of constructions are equally well represented. Anyone who's been in a home with a small child will know there are a lot of orders, do this, do that, a lot of telling no, but on the other hand, relatively few subjunctives. So Chomsky argued that there was not enough data in the child's world with which to acquire the richness of human language. The poverty of the stimulus argument was often combined with the critical age hypothesis. This refers to the notion that children can only acquire natural language before a cut-off date, usually coinciding with around puberty. Evidence for the critical age hypothesis comes from, amongst others, children who have been abused or deprived of contact with human language. There are a number of such cases, for example, Jeannie and Isabel, whom you've heard about in other modules. Interestingly enough, children who had been deprived of language but were rescued while they were still relatively young managed to acquire language fairly quickly and effortlessly and catch up with their peers, whereas children that were rescued after puberty found it much harder and in some cases never developed language. The critical age hypothesis seems to indicate that there's a biological basis for language. In other words, language is not purely cultural. From this, it is a relatively short step to say the biological basis of language surely includes some type of universal grammar. Over the years, there have been a number of criticisms of this approach. For instance, it has been demonstrated that there are a wide variety of linguistic constructions used at homes, that children are exposed to lots of different types of language, and that given this, perhaps the poverty of the stimulus is a little overstated. Personally, I prefer another kind of argument that comes from language acquisition context. I'm going to call it the richness of the stimulus. If you leave a recorder in a room in a home and then come back an hour later to listen to the kinds of sounds on it, you'll find that it is incredibly rich. There are telephones ringing, there are adverts on the TV, there's the sound of lawnmowers, the neighbors might be having a shouting match, cars drive past outside, alarms go off in the neighborhood, some people are talking. Behind the people talking, there's often a TV or a radio playing music. In fact, the ambient context of a typical home is characterized by extremely rich auditory stimuli. In this context, one might expect that a language learner would find it difficult to know which sounds are meaningful and which aren't. A purely behavioristic learner, such as a parrot, might be expected to acquire a whole lot of sounds that aren't linguistic sounds. For instance, a parrot might acquire the sound of the telephone ringing, whereas as far as I know, no child has ever acquired the sound of the telephone and mistaken it for language. So how would children know which sounds are language-like and which sounds are just sounds? It seems to me that universal grammar in the mind could be useful in forming a predisposition to work out a priori which sounds are relevant and which sounds are not. Another argument for universal grammar comes from early studies of the brain. It was discovered that there were two parts of the brain that were useful for language, one called Wernicke's area and one called Broca's area. Wernicke's area was linked to meaning and concept formation, while Broca's area was linked to motor control and phonology. Hospital patients who had damage to either of these areas developed different kinds of symptoms called aphasia. So it was a natural thought for many people to think that since areas of the brain seem to deal with language, that perhaps there was a biological basis to language after all. And if there's a biological basis, the argument for universal grammar becomes much stronger. More recently, however, it's been found that this research perhaps overstated the case. Research has shown that these areas are also used for other things, and that a wide variety of brain areas are used to produce language. So it is far from the case that there is a single part of the brain that produces language. So language may be modular from the perspective of mind, but apparently not from the perspective of the brain. So it turns out that these arguments are perhaps not as strong as we originally thought they might be. Another type of argument comes from language creation. For example, when people from two different languages or cultures come together, perhaps to trade, they might develop something called a pidgin. A pidgin is a limited kind of language, often omitting a lot of nuance and including just a few words, and it is quite similar to what we might think of as foreigner speak. What is really interesting, though, is when pidgin speakers have children, their children create rules where there were none before. In the process, the pidgin turns into a language with all the complexity of any other natural language. We call these created languages creoles. Now, if language were purely cultural, we would expect children to acquire the pidgin more or less intact. However, what seems to be the case is that children take the pidgin and modify it to create a nuanced natural language from it. What motivates this? So one answer might be is that although the pidgin language is in the social context where children are learning language, children are actually drawing on universal grammar in order to actively construct the language in their own minds. Another example of this kind of phenomenon comes from Nicaraguan sign language. In Nicaragua, there was no sign language. Children who were born deaf didn't learn any sign language at all. Their families just made do. And at some point, a lot of these children were sent to a particular school. So at the school, you had a lot of children who were not able to speak orally, who had not been trained in any kind of sign language, and had very little way of communicating with each other. The miraculous thing that happened over time, however, was that the children invented a sign language that had all the characteristics of other human languages, and in fact has a lot of similarity to other sign languages around the world. The spontaneous creation of language in this fashion suggests that language is not purely a social phenomenon, but must have some kind of biological basis. We could ask ourselves, what motivated Nicaraguan deaf learners to spontaneously and unselfconsciously create a language? The answer might be something like universal grammar. Another very interesting argument for universal grammar comes from the case of a linguistic savant called Christopher. Christopher is severely mentally disabled. He needs permanent care. He's not able to do any kind of mathematics. He cannot do his own shopping, and he cannot tie his own shoelaces. But from a linguistic perspective, Christopher is an absolute genius. He speaks something like 16 different languages and can acquire them really quickly. In fact, he learned Dutch for an interview in just 2 weeks using a dictionary and the newspaper. So Christopher is an interesting case because his language faculty is really well developed, but his general intelligence is not particularly strong. Incidentally, this shows that language ability is not linked to general intelligence. Christopher has been a part of a number of experiments, mostly conducted by Professor Neil Smith from University College London. In one set of experiments, the researchers took a group of university students who are highly intelligent and set them a simple linguistic puzzle. They gave the same puzzle to Christopher. The puzzle consisted of having to learn an invented language, but which included one rule which we know that no natural language has. In other words, this was a rule or a pattern that could be inferred using general intelligence, but had no linguistic basis. The researchers expected that, in fact, the highly intelligent university students would be able to solve the puzzle easily, whereas Christopher would struggle. In fact, the findings were even more interesting than that. Neither the university students nor Christopher were able to solve the puzzle. What this suggested is that the patterns that we might find in language are quite different to other kinds of patterns that we might find in the world. In other words, languages do not vary infinitely, but there are definite limits to the kinds of structures and the kinds of patterns that we find in language. Again, this would be unexpected if language was simply a matter of learning behaviors in a behavioristic way or in a cultural way. We could ask ourselves, where does this restriction on the possible patterns in language come from? And the argument might be universal grammar. Another reason that we might want to draw on universal grammar is because it makes good scientific sense to develop generalizations and to use those generalizations to explain other phenomena. Generative grammar has been extraordinarily powerful and successful. So even if you don't particularly subscribe to the notion of universal grammar, having a useful set of tools to understand and explain the structure of the world's languages is useful in its own right. Ultimately, even if universal grammar were disproved tomorrow, the theory would still remain useful. So what do we mean when we say that even if universal grammar isn't real, it would still be useful? There are many examples of this kind of thing happening in the history of science. For example, when Isaac Newton developed the equations for determining the positions of planets, the question we could ask is, are those equations real or merely useful? At one level, you could say, well, the equations are just mathematical abstractions. They're not real in the sense that they don't exist in the real world. However, many scientists would probably disagree and say that the equations are, in some deep sense, real. Another example starts in the 19th century with studies on electromagnetism, a rather curious force and very misunderstood at that time. Maxwell developed a set of mathematical equations to explain electromagnetism, but he himself didn't think that they were real, but merely some useful equations that helped get the facts right. It was fact only in the 1920s, about 60 years later, with the advent of quantum theory that Maxwell's equations were shown to be not only useful, but actually part of the real world. Last example, in particle physics, there were a number of difficult phenomena that could only be explained by the invention of a small particle called quarks. They came in different flavors, quarks called up, down, strange charm, bottom, and top. For many years, physicists thought that these were just useful inventions to help explain the phenomena, that they weren't actually real. But as time has passed, more complex detectors have been created. It has been demonstrated that, indeed, quarks are real. So even if we don't believe in universal grammar and see it just as a useful set of rules of thumb, there's a very strong tendency for scientists to start to see their generalizations as being real. Consequently, time will tell if universal grammar is truly real or just a useful set of theoretical abstractions.